I'm Fatima Bahrani from AstroTeach, and it's truly an honor to be here today with you, Professor Jim Bell, a planetary scientist, author, and someone whose work has literally shaped how we see Mars and beyond.
Yeah, so my name is Jim Bell. I'm a professor in the School of Earth and Space Exploration at Arizona State University. I am a part astronomer, part geologist. That's my background, and I'm what our community calls a planetary scientist. I study the objects in our solar system, the planets, the moons, the asteroids, the comets. And so I also get to use data and help collect data from some of the NASA robotic spacecraft that are traveling across the solar system, like Mars rovers or orbiters around Mars or asteroids, those kinds of things. So I got interested in this stuff when I was a kid because when I was a kid, uh, there were guys driving cars on the moon on television. And that was just the coolest thing, right? For a kid, it was like, wow, I want to do that someday. I still haven't been able to do that, but maybe someday, who knows? Uh, One of some of the work that I did for my PhD thesis was looking at Mars through telescopes. Every 2 years or so, Mars comes relatively close to the Earth, and so it's a good time to look through telescopes. And I was using a spectrometer to try to figure out what kinds of minerals, rocks and minerals, might be on the surface. And so, one of the things that my work helped to reveal is that there are certain kinds of iron oxide minerals, the red rusty minerals that we see in the desert here, elsewhere around the world. Um, there's a certain mineral called hematite, Fe2O3. It's a very common mineral on the Earth in places where there's a lot of water that's weathering the rocks, and we see that we saw that mineral with telescope pictures and data. So I went from telescope work to more spacecraft work when those opportunities came about, and I've had the amazing good fortune to be involved on the science and engineering instrument teams of all of the rovers that NASA has sent to Mars, starting early in my career with the Mars Pathfinder. Since then, I've gotten to lead or be involved with the camera teams for the Spirit, Opportunity, Curiosity, and Perseverance rovers on Mars. I'm also involved in a mission that we are leading the effort here at ASU to study one of the asteroids in the main asteroid belt between Mars and Jupiter that is called Psyche. It seems to be made of, or at least partly made of metal, like it's metallic, and we think Psyche is a survivor of that. We think it's a maybe a big piece of a core of a planet that was forming early in the history of the solar system 4.5 billion years ago. And they're all trying to focus on mostly on places that were where water was in the past. You know, Mars seems to have had this history that was a lot made it a lot more like the Earth early in the history of the solar system, and then something changed dramatically very early, and it dried up. But there were rivers and lakes and maybe small seas on Mars, just like on the Earth, uh, 3, 4 billion years ago. And of course, we wonder, was there life on Mars? Is there still life underground on Mars? Probably simple, bacterial, single cell, multicellular, who knows? There doesn't seem to be any evidence of intelligent life, no cities or civilizations or anything like that that we've been able to detect. But maybe simple life formed on Mars, and that guides us, that compels and motivates NASA and other space agencies to explore Mars in detail. Um, we intentionally landed the rover inside of a crater that has a river that had a river flowing into it, and that end of that river created a beautiful delta like the delta at the end of the Mekong River in Vietnam or the Mississippi River in the U.S. Just a beautiful fan of sediments, and we've been able to drive the rover remotely, remote controlled, drive it up onto that delta and take samples of that material, and we see evidence of watery minerals and clays and carbonates and sulfates and the kinds of many of the kinds of water formed minerals that we see here on the earth tells us yes, there really was water there.
As you mentioned, you helped prove water existed on Mars. What moment made you think this changed everything?
It was much more habitable, what we would call habitable, as a planet, like the Earth is habitable for life as we know it. Mars was like that, maybe not entirely like the Earth, but much more like the Earth than it is today. So, what happened? What happened? On Mars, we're collecting samples, we're drilling into the rocks, collecting samples, we're putting them in little tubes. This is an example of a tube. It's the right size. This one's made out of plastic, not titanium, but there's a little sample in here of rocks. Now we've got more than 20 of them collected inside the rover. And we need to figure out how to get those samples back to the Earth because we can't study them in great detail on Mars. We need to bring them back to all of those amazing laboratories and universities around the world for detailed study. Is there any evidence of life in those samples? Is there evidence to support the hypothesis that Mars really was a lot like the Earth a long time ago? We need the instruments in Earth laboratories to do that. So we have to figure out how to bring these rocks back. And that mission is called Mars Sample Return. And nobody knows exactly when it's going to happen. I mean, there's been a number of them. Every time a rocket launches, every time a mission lands, it's a pretty memorable moment. But one of my favorites was in in early 2004. Um, both the Spirit Mars rover and the Opportunity Mars rover landed successfully on Mars within a few weeks of each other, and they were on opposite sides of the planet. And there was a time for much of the first half of that year when I was part of a small team of people who were working to operate cameras and other equipment on both those rovers. And they were on opposite sides of Mars, and so the sun would rise on one and set on the other, and we'd be working on that rover, and then the sun would set on that one and rise on the other one, and then we'd have to go work on the other one on the other side of the planet. It was like the craziest interplanetary jet lag you can imagine, and none of us were sleeping at all, but we were relatively young and crazy, passionate, and tired but happy, and it was just like an amazing time to be helping to guide two robots at the same time on another planet, both of which were in crazy, incredible places, and to be just physiologically all messed up. But that was also very fun.
What's your favorite space fact that even amazed you?